Good day, everyone. My name is Mohamed Lamin, and I'll be walking you through our project on data augmentation for low resource intent recognition. So the intent recognition task is a part of the automatic speech recognition, where we will try to recognize intents from voice data. So normally you would want to take the data from voice and turn it into text data, and then do your downstream task there based on the pre-existing models. But this will require an enormous amount of data for the language itself to translate the data from voice to text, and then for the downstream task. This is also apparent in low resource settings where there isn't enough data for both of the tasks. We will try and work on this problem by extending on the work our mentor worked on using Allosaurus as a phone recognizer to do intent classification task on the Garbo dataset, which is a collection of recordings for different commands for Flemish language. So we have two tasks for our project. The first one is to come up with data augmentation techniques in the voice phoneme and in the voice space, and then the second one is in the phoneme space. So for the voice augmentation, we try to implement spec augment, which is a well-known voice augmentation technique, but it didn't bode well with Allosaurus, and the resulting phonemes were not very good. So we decided to come up with our own methods where we did two things: changing the speed of the voice data and changing the volume of the voice data. After doing many experimentations, we found that changing the speeding up the data by 1.6 times the original speed and increasing the volume by 5 decibels gave us the best results. So we did a random mixture between these two techniques to give us our augmentation technique. For Allosaurus augmentation, we decided to add classification noise to Allosaurus. So Allosaurus works as a normal classification model where we will have a prior to a linear layer, which we will have probability results. Then we will, instead of choosing the most probable results like you will usually do, study to take the second most probable phone and then use that for our data, which can double the amount of data that we have. For the similarity augmentation, we have our model basically is a CNN LSTM model. So we decided to use the CNN part as a feature extractor. So after we pre-train the model fully on our data set, we will then use the CNN part to get our phone embeddings. Then we will do a similarity checking or custom similarity between our input phones and all the phone embeddings here to come up with the most similar phones and replace a phone with that one. So as results, for the two intent classification task on noise augmentation, we found out that the performance was similar to our baseline. It was the same also for the four intent classification. Here we try to change one or two phones with the second most probable phone. For our voice augmentation, again, there is also a quite similar to our baseline, both in the 2 and 4 intent tasks. When we combine the voice augmentation and the Allosaurus noise augmentation, we found that yes, in the two intent classification task, the performance was worse than the baseline, but still it was in a range that we deem acceptable, as it's not worse than 50% of the data of the performance. But in the four intent classification task, we found that the augmented data performed better than the baseline data, so which was an interesting piece of result. Finally, in the similarity checking part of augmentation, we found that for the two intent classification task, when we change either one or two phones, the performance was quite similar to our baseline. So in conclusion, we came out with 3 different data augmentation techniques that all worked very well on our Allosaurus data sets and Allosaurus use data sets to give us good performance on intent classification, both in 2 and 4 intents on a small or low resource language. Thank you very much.